Next up is our panel Q&A session. Our first question is that, and Kyle, in your talk, you mentioned that you can have more produced fluid than you actually get back oil. Is that the case in all places, in all states, or is that a rarity for Oklahoma?
I think there are some parts of Oklahoma where there's more produced oil or gas than water, but I think that's pretty limited. It's mostly, I would guess, the Granite Wash region in western Oklahoma, where there are more conventional sandstones. But I would imagine that the ratio of water to oil or gas is probably greater than 1 in most parts of the country, and absolutely in most parts of Oklahoma.
Great, thank you. The next question we have is that, can these reuse methods discussed for produced water from oil and gas be used for produced water from other processes like wastewater treatment and other industries?
Yes, indeed. Actually, produced water treatment often borrows from methods developed for other uses. So, for example, removal of organics using activated carbon or gas flotation. These are methods that have been developed for industrial uses already. There's a lot of crosstalk right now in adapting methods of treatment from industry to produced water, because produced water is a relatively complex water. So it's going to take a little bit of effort to try and best match the methods to the water.
Great, thank you. The next question is for Holly. Given the limitations in being able to analyze all of the constituents that may be found in produced water, as well as the lack of regulations for some of those constituents, is reuse for agriculture or other uses that involve exposing that water to the environment practical, or will we reach a regulatory paralysis?
I can't speak to whether we'll reach a regulatory paralysis. I do think that there's momentum behind the idea, and that regulators in many states are trying to work through this issue. And rightfully, they should be concerned about some of the unknown constituents and inability to test for them. That said, there may be options to use whole effluent toxicity evaluations to get at some of the unknown constituents or other protective measures. But I think proceeding slowly is probably the best course of action. I can't say whether that will be a full stop or not.
Great, thank you. Our next question is, how big of a problem is the disposal of recovered waste from the water purification process? So that relates to your talk, Jeri.
Well, one of the advantages that the oil and gas industry has is that they have a built-in disposal process that is already well understood and well covered in the regulation, and that is the use of Class 2 disposal wells. So that's why I like the idea of taking produced water and treating it for reuse, because you already have this process in place, and so it's well understood. And the key is going to be that having the treatment near where the disposal locations are. And if you start doing treatment elsewhere, then you've got a transportation issue. But if you keep your treatment near where this disposal infrastructure is, then you have a real advantage.
Great, thank you. The next question is, have there been studies on oil and gas production after hydraulic fracturing when using produced water versus fresh water as a base for the frac fluid? And if there have been those studies, what have they shown? And anyone's welcome to answer that question if they know much about that.
Yeah, I haven't done those studies myself, but my understanding is that hydraulic fracturing with reused water or produced water tends to be create a better production well in the end, because you're using native formation water. As long as it's produced water from the same formation, it's going back into that formation in a new well, it tends to improve the production of the new completion. But I don't know exactly what source that's from. It's based on several talks that I've seen over the last few years.
This is Holly. I'll jump in and say that I have heard the same things Kyle just discussed. And we'll note that the research done may not be in the scientific community or peer-reviewed, but certainly the larger producers and service providers like Halliburton have evaluated that question and long-term effects of production. And so if you're interested in that work, I might look to those commercial sources.
Great, thank you. So the next question is for Jeri. Have zeolites or similar materials been used to try and selectively extract important or strategic materials from produced water?
Ooh, that's a good question. I know that zeolites have been used to extract, for example, radioactive materials from wastewaters. And I know that they can be used to extract certain cations from wastewaters. However, I am not aware of any studies where they have been used specifically for produced water and as well as specifically for extracting valuable minerals. I think it would be a great area for future research, however.
Great. The next question is there concern about disposal or soil buildup of radionuclides from treatment or reuse of these waters?
I might answer that to some degree. I think that there certainly should be some concern because the naturally occurring radioactive material norm typically is associated with calcium, magnesium, barium types of deposits that might occur in scaling. So if we dispose of produced water and there's an opportunity for those elements to precipitate out, the level of norm would probably increase along with the scaling material. So if it's not a concern or it's not on the radar, it should probably be on the radar for operators to make sure it's managed properly.
Great. We've got time for maybe a couple more questions. The next one is for Holly. How does New Mexico define a spill, and has that definition led to the increase of spills at all?
New Mexico has a fairly detailed definition of a wastewater spill or oil and gas fluid spill that I don't have at the top of my tongue. Certainly, the EE News study I cited does discuss the effect of a spill definition, a spill size definition, on the numbers. I think particularly that spill increase number in 2013 for North Dakota probably reflected a change in their definition of spill size. But unfortunately, I can't say exactly if that is the case for New Mexico as well. Maybe Jeri might have some insights.
I don't think the definition changed. I think if there was an increase in spills, it was likely just due to the increase in operations that happened with the upturn.
Great. And our final question will be that polluted water is often naturally remediated by soil. Why isn't this a solution for what to do with produced waters? Is it something to do with the nature of the produced water?
I think
Sure.
it goes back to the produced water. The constituent of greatest concern in my mind is the salt content, the high total dissolved solids concentration, which is very difficult for a natural system to remediate. Salt doesn't degrade and form its components, such as an organic material would degrade and form CO2 or methane and be broken down, but the salts don't really break down.
Great.
That's exactly right.
Agreed. Unless you have a mechanism to flush the salts, then they're going to remain in the soil.
Great. That's all of our questions for today's webinar. If you have any questions that weren't addressed today, you can email them to the address on the screen, which is cipinfo@americangeosciences.org, and we'll send our questions along to the speakers if they have a chance to answer them for you. We'll also be posting today's recorded webinar on our Critical Issues web pages soon, and you can visit the website also on the screen there to view this webinar as well as our previous ones.